Well, here we are again for Advent of Code. It is now day 16. We're doing it in Rust. Let's get into it. All right, today's problem is called Packet Decoder. As you leave the cave and reach open waters, you receive a transmission from the elves back on the ship. Their transmission was sent using the Buoyancy Interchange Transmission System, BITS. Cute. A method of packing numeric expressions into a binary sequence. Your submarine's computer has saved the transmission in hexadecimal, which is your puzzle's input. The first step of decoding the message is to convert the hexadecimal representation into binary. Each character of hexadecimal corresponds to 4 bits of binary data. The bits transmission contains a single packet at its outermost layer, which itself contains many other packets. The hexadecimal representation of this packet might encode a few extra 0 bits at the end. These are not part of the transmission and should be ignored. Every packet begins with a standard header. The first 3 bits encode the packet version, and the next 3 bits encode the packet type ID. These 2 values are numbers. All numbers encoded in any packet are represented as binary with the most significant bit first. For example, a version encoded as the binary sequence 100 represents the number 4. Packets with type ID 4 represent a literal value. Literal value packets encode a single binary number. To do this, the binary number is padded with leading zeros until its length is a multiple of 4 bits, and then it is broken into groups of 4 bits. Each group is prefixed by 1 bit except the last group, which is prefixed by a 0 bit. These groups of 5 bits immediately follow the packet header. For example, the hexadecimal string D2FE28 becomes this binary string which is then converted into these sections, which are labeled using specific letters. Below each bit is a label indicating its purpose. The 3 bits labeled V110 are the packet version 6. The 3 bits labeled T100 are the packet type ID 4, which means the packet is a literal value. The 5 bits labeled A10111 start with a 1, not the last group, keep reading, and contain the first 4 bits of the number 0111. This sounds a little bit like Unicode, actually. I think UTF-8 has a similar structure to this. The 5 bits labeled B11110 start with a 1, not the last group, keep reading, and contain 4 more bits of the number 1110. The 5 bits labeled C00101 start with a 0, last group, end of packet, and contain the last 4 bits of the number 0101. The 3 unlabeled bits 0 at the end are extra due to the hexadecimal representation and should be ignored. So this packet represents a literal value with binary representation 0. Okay, so yeah, this is basically just a number, which is 2021 in decimal. 0111, which is here. 1110, which is this B section. 0101 is the C section. And this is 2021 in decimal. And interestingly, I think this is actually interpreting the decimal, interpreting this binary value using little endian, or rather big endian. So, well, which is which? Big endian, I think the most significant bits come first, right? Big endian stores the most significant byte at the smallest memory address. So I guess maybe endianness is not quite. It's endianness of the bits. The most significant bits are interpreted first for this binary representation of the number, but the least significant bits Oh, okay. You know what? It's the same. I thought there was a contradiction between the way that it was interpreting these numbers and it was interpreting this number. So we're good. Every other type of packet, any packet with a type ID other than 4, represent an operator that performs some calculation on one or more subpackets contained within. Right now, the specific operations aren't important. Focus on parsing the hierarchy of subpackets. An operator packet contains one or more subpackets. To indicate which subsequent binary data represents its subpackets, an operator packet can use one of two modes indicated by the bit immediately after the packet header. This is called the length type ID. I feel like I'm reading the manual to like the USB protocol or something like that. If the length type ID is 0, then the next 15 bits are a number that represents the total length in bits of the subpackets contained by this packet. If the length type ID is 1, then the next 11 bits are a number that represents the number of subpackets immediately contained by this packet. Finally, after the length type ID bit and the 15-bit or 11-bit field, the subpackets appear. For example, here is an operator packet, hexadecimal string blah 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 blah, with length type ID 0 that contains two subpackets. The 3 bits labeled V are the packet version 1. The 3 bits labeled T are the packet type ID 6, which means the packet is an operator. The labeled bit I is the length type ID, which indicates that the packet is a 15-bit number representing the number of bits in the subpackets. The 15 bits labeled L contain the length of the subpackets in bits, 27. The 11 bits labeled A contain the first subpacket, a literal value representing the number 10. The 16 bits labeled B contain the second subpacket, a literal value representing the number 20. After reading 11 and 16 bits of subpacket data, the total length indicated in L27 is reached, so parsing of this packet stops. Another example, here is an operator packet, hexadecimal string blah, with a length type ID 1 that contains 3 subpackets. All right, that's a big example there. After reading 3 complete subpackets, the number of subpackets indicated in L3 is reached, so parsing of this packet stops. For now, parse the hierarchy of the packets throughout the transmission and add up all of the version numbers. Here are a few more examples of hexadecimal encoded transmissions. So there's some examples here. They're giving us lots of examples because I think these directions are a little bit fussy. Probably not any more fussy than any other binary encoding, but they've invented a binary encoding out of whole cloth in this puzzle. Or I don't know if it's out of whole cloth. It could be inspired by something in real life. But these are always really finicky to work with, right? Operator packet that contains an operator packet that contains an operator packet that contains 5 literal values. Okay, well, as I was reading this out loud, I think it kind of went over my head how complicated this was. So I'm going to have to read this a couple of times to really get it, to really be able to do anything useful with this information. At the very least, wow, okay, so this is like one giant hexadecimal string. At the very least, we can just like start copying our input and just see if we can do the barest amount of parsing here. What we would like to do is just take the input and convert it into bits, byte over byte, right? And essentially every single byte or every single character will represent 16 bits of our input. Is that right? Or not 16 bits, sorry. 4 bits. A hexadecimal character is encoded as 2 ASCII characters, and that represents 8 bytes worth of data. Okay. So what we really want is just like a stream of bits, I guess. So our bits is equal to get input. Oh, I need to reload. Reload the text editor so that Rust Analyzer recognizes the new directory. Something I forget to do all the time. It's a little bit annoying that I have to do that, but so be it. So we want to go character by character, right? Maybe we want to flat map this. So this is a we get one character, and we can return an iterator. Or really what we do is return... We just want to return, like, essentially a iterator that yields 4 individual bits, right? So we have a character, we want to convert it into binary, and we want to stream out bits as a result. Is there an easy way of doing this? We essentially just want to get the bit value of each character. Well, we could just read this character to an integer, or U32, with the radix 16, right? And with a radix of 16, we should just get this, and then this is our value. And what we're really returning here is kind of like a vector of whether or not the first bit is set, or the most significant bit is set, whether or not the 8th bit, the second bit is set, the third bit is set, and the fourth bit is set. So what does that look like? Is this just Booleans? My bitwise operations are a little bit rusty. It's been a while since I've done C, and I haven't really done this in Rust before, so bear with me here. We could do val and this not equals 0. I don't think I'm encoding these binary values correctly. Rust, binary, literal. How do we type them? Zero B is correct. And then this is meant to be a bitwise AND. This is an, oh, I see, saying this is an option. I gotta unwrap this. Okay, yeah, so this is an iterator of a Booleans. I think this is basically what we wanted to do. I'm gonna go ahead and maybe it will be better if we just materialize this and print it out. It's gonna be easier to work with that way. And let's do something with our input that's really, really simple. Let's just do the number 1. Or the number 1 and then the number 2. Let's actually do a few different things. Let's do 1, 2, A9. Is it going to be easier to just use 1s and 0s? I think ones and zeros would just be easier to read. So let's just map true to 1 and false to 0. Okay, 0, 0, 1 is indeed the number 1. 0, 0, 1, 0 is indeed the number 2. 1, 0, 1, 0, is that 10? Let's see, that's 8 plus 2 is 10. And then 8 plus 1 is 9. Okay, so I think we did that correctly, right? So we now have our stream of bits. Great. Okay, so now it's a matter of just like interpreting these really complicated encoding formats here. Okay, so we have a packet which contains a bunch of other packets, right? It's a recursive structure. It's a packet version and a packet type ID. What does the version matter? The version is what we're trying to find, right? We're just trying to add up all the version numbers that we discover, but I don't think the version is actually used anywhere in the interpretation of the format. The version is literally just, as far as we can tell, data so far. Maybe it'll come into play in part 2. The type ID is actually the really significant thing, because the type ID seems to be the thing that is like telling us how to interpret this data. Okay, so let's oh, I think I'm getting a phone call here. Let's let me take this real quick. All right, sorry about the little interruption. We are back into it. I think what I was saying before is that the type ID is really the significant thing that we care about, although the version number is gonna help us get our answer for the actual problem. The type ID is gonna, again, tell us how to interpret the data. So the version is just the first 3 bits. The type ID is the next 3 bits, right? Yep. And then the type ID, look, what type IDs do we know about so far? We know a type ID 4 is a literal. And then any packet with an ID other than 4 is an operator, which does some kind of calculation. An operator contains 1 or more packets. An operator can use 1 or 2 modes. So there's a bit immediately after the packet header called the length type ID, and then 0 and 1 basically tells us, it just tells us how long this particular packet is going to be. Total length in bits. If it's 1, the next 11 bits are a number. Okay, so this is like almost like an immediate value in assembly language. Okay, cool. Let's go ahead and get into it. Would it help for us to actually create some data structures for this? Right, so we could have an enum of operator. And we have 2 different kinds of packets. The first packet is a literal packet, right? And what exactly is a literal? A literal is just a... Is it a number, or is it like a string of values? Do we want to, like, I'm just trying to think about how I want to encode a literal. Is it like a vector of bits? It encodes a single binary number. Okay, so literal, let us call it an I64 for now. And then an operator is going to be a vector of packets. Is that right? We don't know what the op is yet, so right now I think for the operator, it's just going to be some kind of type ID, which we'll encode as a U8. It's called just the type ID. And then it's going to have a vector of subpackets. Okay? So let's go ahead and set up an iterator that we can just like chew bits off of. So really, I guess at this point we don't need to collect it again. We can just treat it as the iterator there. Let's get rid of this. So now it's an iterator of our I32s. I want these to be U8s actually. Let's just make them small. It's not super important, but it makes a little bit more sense for them to be ones and zeros with just only a byte representing them. And let's go ahead and while let some bit, or rather what we should do while bits.has next, does that exist? I don't know if there's a way to peek into an iterator and just say, hey, do you have anything else? Because I don't necessarily want to consume, I want to be able to peek into that. I guess we could just loop. So what we're expecting right now is to be, we're going to basically consume an operator, right? Or consume a packet, right? Maybe we can make a function, right? Fn read packet, and we're going to get a mutable iterator. Bits is a mutable iterator whose item is equal to U8, and it's going to return a packet, right? So what we're going to do is we're going to read off the first 3 bits, which is going to give us the version value, version number. Oh, and where do we put the version number? Maybe it's going to be something like this. Maybe let's make this a little bit more legible, right? It says a literal packet. Make an operator packet, which has a version. It has an operator ID. Let's just call it the type. Can't put an E on the end because that's a reserved word in Rust, so I'll just do TYP. And then let's say subpackets. Okay. Now the literal will be a literal of a literal packet, and the operator will be operator of operator packet. Okay, so we're going to read 3 bits. And we're going to want to know how to basically convert a big endian vector of bits into a number. right? And let's assume unsigned everywhere for now. What would be the right way to do this? I guess we can parse a string. How do we parse a binary string in Rust? iSize from string radix. What on earth is iSize? This is like a usize, but it can go negative as well. So I wonder if there's usize from string radix. Yes. Maybe what this means then is that this should be an iterator over characters. And this instead should be 1 and 0. The reason why I'm converting this into characters is that I can basically join them together into a vector and then parse the strings that way. And then Rust iterator consume n consecutive. How do I get multiple items and collect them? I basically want to create another iterator that gives us the next n number of items. Is that a partition, maybe? I can always do this manually, but it would be easier if there was a function that just gave it to me. Take yields the first n elements. Perfect. This is exactly what I want. So I'm going to take the next 3, and we're going to collect them into a string. And then the version is going to be usize from string radix. The source is version bits. And the radix is 2, right? And the only thing we need to make sure that we understand here is whether this from string radix can handle fewer than 8 bits. So why don't we do something like this? Fn, read version string. This is going to be the same thing, our iterator over char, and this will return a U8. And let's just go ahead and do this. Just copy this over and return this with an unwrap in front. Okay, let's see. Usize from string radix. This is the usize. How about U8? Will this work from string radix? Okay, perfect. Okay, I'm really glad that that was doable there. So what I'm just gonna try to do is see if I can't read the first 3 bits off of some sample input and print out the version string and just make sure we're doing that correctly. Where is our example? I think this is our example. So let's go ahead and do this and just like read off the version string. And let's hope that we get the number 6. All right, our iterator needs to be mutable. Yes. This implements an iterator. Let's collect this back into a vector. And then let mute bits iter equals bits dot problem is bits.iter is going to be an iterator over references to characters. Oh, you know what it is I think something just added an extra ampersand mute there. So will this work again if I just make bits the iterator? Sorry, I'm fighting Rust here a little bit. Bits, consider mutably borrowing here. So it looks like because I'm not materializing it, I need to keep the input around. Or else it'll go out of scope. And okay, that finally seems to be type checking correctly. Did I print anything? It printed out 0. Oh, you know what? Because this is not hexadecimal. This is not hexadecimal. This is the hexadecimal that we actually want. 6. Okay, that's pretty good so far. We were just really trying to test how this string from radix function is working. Okay, so the next thing we want to do, that's how you parse the packet version. Now we want to parse the packet type ID. It's going to be the same code. I'm going to keep it separate just because it looks similar, right? And let's get our read packet back in, because this is how we're going to use it in this context. Packet. So let version equals read version string bits. Let type ID equals read type ID of bits. And let's just call this read version. String is a little bit of a superfluous part of the name. Trait objects without dyn are explicitly deprecated. Is it nmute dyn? Iterator? This is just saying that we essentially have a fat pointer to an iterator. Okay, that seems a type check. We have a version and a type ID. Okay, so next, if the packet type ID is 4, the packet is a literal value. If it's 4, we're going to create a new literal packet. And the literal packet broken in groups of 4 bits. These groups of 5 bits immediately becomes the packet header. For example, the hexadecimal string this becomes blah. So we need to be able to read a literal. And that's all this stuff, and we're going to be returning a U64 at the end of this. So what we want to do is collect the bits that we care about, right? Because we're going to be reading in 4 bits at a time, and then the first bit is going to tell us whether or not we need to continue. Should do this binary numbers pattern with leading zeros until its length is a multiple of 4 bits. Then it is broken into groups of 4 bits. Okay. Each group is prefixed with 1 bit, except for the last group, which is prefixed by a 0 bit. So we're going to read 4 bits at a time. Let's call this a vector of characters. We're going to bits.take 4 bits and collect that into a vector. And we're going to be accumulating literal bits. We're going to be accumulating a vector of bits. And let last equal to... Let's actually do this. Let last equals bits.next.unwrap is equal to 0. This will tell us if we're in the last bit or not, right? And then the bits that we want are going to be the next 3 bits. So we really just want to append the next 3 bits onto literal bits. So literal bits.append, and it takes another vector. Can we append an iterator to a vector? Feels like we should be able to. Is there an append iter? Rust append iterator to vector. Extend. And then if it's the last, we break. Okay, it's just complaining that we haven't finished yet. I guess we can just do a return here. If last, return U64 from string radix literal bits dot collect. And the radix is 2. And I think this needs to be a string. And then this needs to be, let's see, what are you complaining about? And we have to unwrap. Trait bounds are not satisfied. Vecchar iterator, which is required by a mute vecchar. Probably shouldn't use the word str. Let's call it the bit string. Oh, it is. I just need to convert it into a string. So if a vector of characters into a string, char vector to string. There's probably some kind of like into iter collect. Can we just do iter? All right, so that's how we read a literal. So if it's 4, we're going to do read literal of bits. And this is actually going to be a packet.literal. And this is going to be a literal packet whose version is the version value and whose literal is read literal. And colon here, not dot. Oh, I called this val. Value of the literal. Okay, and then it's expecting an expression here because I don't think I closed this parenthesis, right? And now it's complaining because I don't have a default here, non-exhaustive pattern, which is okay because the result of this is going to be, maybe I should return the packet literal from, well, no, this is fine. Can I borrow literal bits as mutable? Okay, so this is going to be a packet operator. And it is going to be an operator packet whose version is here, whose, let's just call this type ID. I don't know why I didn't do this in the first place. And whose subpackets are some function here, right? And maybe we should just make a function called like read operator packets. And this doesn't exist yet because we'll make it right now. Similar pattern here, except that this is going to be a vector of packets. All right, so let's go to the directions of how to read an operator subpacket. The next bit is the length type ID. Next 15 bits are a number that contains the total length in bits. Otherwise, we're reading a number, the number directly. So let's do a match on bits.next.unwrap. And if it's 0, let's actually make a variable. Length type ID is here. Just so we can give it a name. It's a little bit clearer if we give it that variable name. If it is 0, next 15 bits are a number that basically gives us the total number of bits to read. Otherwise, for 1, this gives us the number of subpackets. Okay, so let's do the 0 case first. Let's read the next 15 bits, read that into a number, and this tells us the total length in bits of the next subpackets. We're going to take 15 bits. We're going to collect them into a string. And then we're going to use useSize from string radix. It's binary. Okay, so I think this is fine. It's just complaining that we haven't returned a packet yet, or vector of packets. So let subpacket bits equals bits.take n bits. Right, so this is the number of bits that we have, the number of bits that we have for this, for the subpackets of this operator. And we basically need to read packets out of that until subpacket bits is exhausted. So can there be bits at the end of the iterator that are just not used? We just throw them away. I think it said something in here where that was possible. The 3 unlabeled bits at 0 are ignored due to the hexadecimal representation. Okay, so we can't ignore bits at the end. So this is a little bit tricky. This bit version of this length type ID 0 is a little bit tricky. Because it doesn't tell us the number of subpackets that we're expecting. So how do we know if we've gotten to the end? Is it that when we read a packet, we need to be able to just... we need to know when we can ignore it? Let's just assume that like we have to consume this entire thing. So let's make a result vector. And let's return that result over here. And now we are going to read a packet. Subpacket bits needs to be mutable. And we're going to pass this in there. N bits. Why is it complaining here? Found result usize. We need to unwrap this result. All right, we're just fixing errors on the way back up. Oh, this should be unreachable. Here. So how do we know when we're done? Yeah. I think it's basically when subpacket bits is empty. But the problem with that is that we don't know whether or not it's empty unless this unwrap hits an error, right? Unless we exhaust the iterator. So what we could do is for every one of these functions, if we every time we call next or take, if we exhaust the iterator, then we could just return, hey, I can't finish this. That's a lot of code to like thread that through. That's a pain in the butt. Another option that we could do is we could read from the iterator and then prepend the value back onto the iterator, which is a little ugly. Rust iterator peak. Is there a peakable? I guess we do convert it into a peakable. let some value we don't care about equal to subpacketbits.peak. While? Okay, this is not, I have a feeling this is not correct code because we're going to try to read packets. We're going to be trying to read bits that may be invalid due to the hexadecimal encoding, but I'm hoping that will not be the case. Let's try it for now and see if that edge case matters. So basically, as long as we continue to have bits in our subpacket chunk, we're just going to continue to try to interpret those into packets and push them onto this vector. If it's 1, then we know how many subpackets we're interested in, right? So let n subs is equal to the next 11 bits, right? And I'm actually going to create a function here. We're doing a lot of this sort of like take some bits well, I was going to say let's like read the next n bits into a U size, but I think we're only doing that twice, so maybe for now we're okay. This is the number of subpackets. Let's just say n subpackets. And then we're going to say for underscore and 0 to n subpackets, res.push read packet from bits. Okay, this is a little bit scary, but I think we should try going for it. Let's derive debug for each one of these. And clone. I think we should be able to copy a literal packet. Whereas maybe we don't want to copy an operator packet because it has a vector inside of it. Packet does not implement debug. Well, it does now. And if we're not cloning operators, it doesn't, or if we're not copying operators, it doesn't make sense to make those copy, literals copy. Okay, so we're able to do debugging right now. Will it panic? 6, the value is 3972. Did we do it correctly? This is 2021 in decimal. All right. Packet type ID, which means the packet is a literal value. The 5 bits. So I think it's this code that we did incorrectly. The 3 unlabeled bits at the end are ignored due to the hexadecimal representation. I think the extra bits due to the hexadecimal really only matter in this first layer of decoding, right? They've kind of dropping I don't think we're ever going to have spaces in the middle of this interpretation. Like this string right here represents meaningful bits inside the bit stream, but I don't think we'll ever have for the entire bit stream spaces in the center of this. That's my intuition here. So what are we doing incorrectly? Let's break it down. We did get a literal packet correctly, and then now we have literal bits. And when we read literal bits, it could be just that's the issue with reading. We just have an issue with reading literal bits, right? And read literal, let's see here. Our last... maybe we can just print the bit string right here. Oops, got to remember to borrow it so it doesn't complain. So the bit string is 0, 1, 1, 1, 1, 1, 1, so 6 ones. 0 with 5 ones. Okay, yeah. So the way that we're consuming these is not correct. Zero, 1, 1, 1. Oh, it's 5 bits. So I think this should be take 4. Let's take a look at that. Okay, yeah, that was the incorrect thing I was doing. So it's a 5-bit grouping. Yeah, when it says that the group is prefixed by 1 bit, I think what I was confused by is what they mean is that you take a 4-bit group and then actually stick another bit in front of it, rather than saying that when something is prefixed by something. I think the way that I interpreted that originally was that the first bit of those 4 bits was was some kind of like identifier. Okay, so I did that correctly. This one is okay, so that's a literal. Let's try doing an operator. It's this example here. Please don't crash. Okay, so is an operator, type ID is 6. The sub packets it's a literal value of the number 10. Okay, that's cool. And then we got a literal value of the number 20. That's cool. So I think you can kind of see where this is going. This is maybe just like the encoding of some kind of computer, right? We're eventually going to probably have to interpret this format into some sort of assembly language or something like that. Or really, this is actually just like the actual machine code. So parse the hierarchy throughout the transmission and add up all the version numbers. So, okay, let's give that a shot. Some more examples. Let's make sure we get, because this is so finicky, I'm going to run all the examples, which I don't normally do, and see if we can get this correct. Okay. Represents the operator packet version 4, which contains an operator packet version 1, okay, which contains a literal value oh, I skipped a line. Version 1, which contains operator packet version 5, which contains a literal packet version 6. This has a version sum of 16. Oh, I see. This sum of 16, I'm not actually materializing yet. I'm not actually calculating it. Let's go through all the examples and just make sure the structure makes sense. It's not crashing so far. That's actually promising. Okay. So the second one is an operator packet of version 3, which contains 2 subpacket. Each subpacket is an operator packet. Okay, so there's an operator packet. Each subpacket is an operator. Okay, so we've got an operator here and an operator here. Each one of them is an operator packet that contains 2 literal values. It doesn't actually go into any more detail than that. Okay, so this does have 2 literal values. This also has 2 literal values. Let's do this one. Maybe I should go ahead and like write the calculation that sums up all the version strings. This looks like a similar structure as the previous one. Same structure as the previous one. Okay. Outermost packet uses a different length type ID. Okay, fine. Last example. Okay, so it is an operator packet that contains an operator packet that contains an operator packet that then contains 5 literal values. 1, 2, 3, 4, 5. Okie doke. So looking pretty promising so far. Let's go ahead and write a function that actually calculates the sum of the version strings, right? And we are just going to have P as the reference to our packet, right? So what we're going to do is we're going to match the type of packet, and if it is a packet literal, this is just going to be a literal version. Otherwise, if it's a packet operator, op, this is going to be the operator version plus the op subpackets dot fold, or rather we can map this recursively. And we'll do the sum versions of sub.sum. Oh, and I need a return value. This should be, what are our version strings? U8s? Let's just make the version strings well, U64s, just because we're going to sum them. I don't want to have to typecast it or anything like that. And where is our summation function? It's U64. This is a map. We got to do this into an iterator. Some versions, plural. Op version as type annotations cannot satisfy add. That's a U64. U64 as add output is equal to U64. What am I doing incorrectly here? Let's just say let foo equals this, and then what we want is op.version plus foo. Now what's it complaining about? We need to give it a type. I see. Okay. So does that mean that sum needs to be type encoded like this? Okay, great. Not going to complain. Oh gosh, why do you have a problem with that? Sum. It's weird to me that when I do this, maybe it's just the semicolon down here that was screwing me up. Okay, yeah, that's fine. But to tell you the truth, I think I like this a little bit better. Okay, so that's our sum versions. So what we want to do is we want to println of our sum versions of this result here. And it needs to be a reference. It's complaining, expected U64, found U8. It's because when we're parsing the versions, let's just be good citizens about it. U8. This is probably the way that you would want to do it if we were writing a real program. And now it's complaining about this because I want to encode this as a U64. Similarly, I want to encode this as a U64. And that should be a little bit more well-behaved. Third 31 is our last thing in here. So I have a reasonable amount of confidence that we got this correct here. Unless we missed an edge case. I'm debugging somewhere, so let's get rid of that debugging code. And let's go grab our original input so long after we originally copied it. And let's go ahead and run this bad boy. 977. My palms are starting to sweat. This is a lot of code. How are we going to do? Okay, whew, we got it correct. That is awesome. Okay, so now that you have structure of your transmission decoded, you can calculate the value of the expression it represents. Before I read further, I'm going to go ahead and commit this project to my Git repository, or commit these changes to my Git repository, and then we can make a copy and freely mutate it or modify it without worrying about losing our work from the first part. $16B, almost ready to go. Let's compile that. It runs. Fantastic. All right. Okay. Literal values type ID 4 represent a single number as described above. The remaining type IDs are more interesting. Packets with type ID 0 are sum packets. Their value is the sum of the values of their subpackets. Okay, type ID 1 are product packets. Their value is the result of multiplying those values together. Packets with type ID 2 are minimum packets. Maximum, greater than. So how do these comparisons work? If their value is 1, if the value of the first subpacket is greater than the value of the second subpacket, otherwise their value is 0. These packets always have exactly 2 subpackets. Okay, so now we just have to like write an evaluation function, right? So rather than some versions, we're going to have like eval, right? And what this is going to be instead is we're going to do lit.value. And this doesn't need to be there. Some versions is gone. We are going to evaluate these and let sub vals, and we're not summing here. We're just gonna let this be an iterator over U64s. And now we're gonna match over the op.typeID. And we have 0, 1, 2, 3. We skip 4 because that's a literal. 5, 6, 7. So 0 are sum packets. So we're going to do subvals.sum. For 1, for here, this is not implemented, unreachable. For anything that's defaulted here. 1 is the product. 2 is the minimum. And I can call the sum, product, and minimum because I think the addition, multiplication, and min operation traits are implemented for U64s. I'm guessing 3 is a max. 4 we intentionally are skipping. 5 are greater than packets. Their value is 1 if the value of the first subpacket is greater than the value of the second subpacket. These always have exactly 2 subpackets. Okay. So 5, we're going to assert that subvals let's just do if subvals.next is greater than subvals.next. Let's do some unwraps here. That is equal to a 1, otherwise it's equal to a 0, right? And then type ID 6 is going to be the reverse of this. Less than. There's no less than, or so there's an equal to here. Operator 7, that's what I was trying to anticipate here. Okay, and it's now complaining about the minimum here. This is an option. Let's unwrap these. Let's unwrap these. And that is our evaluation function. Nice. This is actually one problem where I feel like doing it in Rust helps me quite a bit. Why is it complaining? What is this little underline here? Complaining about unexpected token Rust C. I just don't have a comma at the end here. Got a few problems though. It's expecting a semicolon somewhere. Oh, this is a semicolon, not a comma. Now we're just printing eval, right? Cannot borrow subvals is mutable. That's because I just didn't declare it as mutable. And that is it. The formatting of this is pretty difficult to read, but this is just what the editor wants me to do. I think it's probably because these annotations don't count as the line length here. These kind of virtual annotations, which is, you know what? It's fine. Okay, we got some big number. And we got it right. So that was kind of like a bit of a Hail Mary. But what's nice about doing this in Rust is I think that, like, especially this kind of like type switching is really easy and nice to express. If you just model your problem with the right types, good things come out of that. And by good things, it just makes the rest of your code simpler. Now, theoretically, we could also potentially model these operators as a separate enum type. I don't necessarily think that that's necessary this time around. In fact, potentially we could just have one structure that maybe double loads literals and operators in the same structure, and we have something for the value and something for subpackets. But I think I like this better. This makes it so that like a combination packet that has both a value and subpackets defined would be invalid. And indeed, like we just wouldn't even have to worry about that case if we're using Rust and we structure a problem this way. Very nice. That does it for Advent of Code 2021 day 16 in Rust. A lot of finicky kind of interpretation of instructions, but otherwise maybe pretty straightforward as long as you're used to recursion. Yeah, so that's that. I will see you tomorrow for day 17. See you, everybody.